Hello everybody, welcome to my presentation on heat flow in Europe. Before beginning, I would like to give credits not only to my co-authors shown here, but also to over 125 supporters and contributors from all continents that have worked over years on the assessment of the Global Heat Flow Database, which is maintained by the International Heat Flow Commission and was supported by the International Leadership Program. These voluntary efforts were community-driven and, from my point of view, a fantastic example for global geothermal collaboration. So I would like to start this presentation with a question. Basically, who of you can remember a geothermal project failing due to insufficient subsurface conditions? I think that's quite a lot, and everyone is remembering at least one particular project that failed if we have a lack of information about the subsurface. So on our path to the industrialization of geothermal, many obstacles need to be removed across the technology and the project development chain. So some of these obstacles can be targeted by geoscience, for example, developing exploration methods, and closing knowledge gaps is one of them in order to reducing upfront risks. Because energy companies usually don't want to deal with too much exploration risk. So exploration, the beginning of this technology chain, this is what I'm talking about in this presentation, and this is where we can, from a geoscientific point of view, really make a difference. So the basic questions, where to drill and how deep to drill, this is what we try to answer. And this is where it is connected to the subsurface thermal field, so covering temperature, thermal rock properties, and heat flow as very relevant parameters. I think it is also fair to state that for all geothermal technologies, the extractable temperature is important and is one variable that guides us on our hunch for a geothermal sweet spot. But for some geothermal technologies, these parameters are even fundamental to their business model. So for pre-drilling temperature predictions, for subsurface production measurements or modeling, and for reservoir lifetime analysis, heat flow, temperature, and subsurface thermal rock properties like thermal conductivity are really indispensable. So what is heat flow? Heat flow can express very different things. I mean, it is derived from thermal conductivity and the temperature gradients that both can reflect methodological variable conditions. And in the best case, we strive for terrestrial heat flow, which is the surface heat flow sensor structure, and reflects the heat from the Earth and Terra without any surface relevant perturbations. In this case, heat flow is increased with shallower depth due to the accumulation of the contribution of radiating heat in the subsurface. But quite often, and even more often, we measure something different. A heat flow that is perturbed by other processes, predominantly by surface climate variations into different depths, sedimentation, erosion, things like that. So that needs to be considered. And the problem is, until today, these different kinds of heat flows that has been measured by a lot of people and a lot of scientists in the past stand equally side by side in global databases. And this is because we are often lacking metadata, sufficient metadata to really explain and describe the nature and type of the measurements we have done. And this is a bit a reason from long paths of digitization, of the evolution of methods and technology over the past decades that overall yield to inconsistent database information. So when we started basically with the last publication on heat flow in Europe, which is the EU heat flow Atlas of Geothermal Resources, we were faced with, let's say, ancient data based on old database schemes and insufficient metadata description, where we had a limited quality control and where the question for uncertainty really brought us to laughter sometimes. So in this presentation, I will show you how we have tuned and turned an ancient, incomplete analog compilation of research results into fair, quality controlled and authenticated research database for Europe. So we started with a community-driven development of new standards for the structure and the quality of the global heat flow database some years ago. This was the first step, and it was necessary, let's say, to reflect the different needs of researchers and the need for a new structure according to new database standards. So this new global data standard was also supported by a number of useful tools. So we provided here guided submission templates, for example, also quality check tools to, on the one side, support researchers that provide data to us and that develop data, but also to make it easier for people to understand how the overall database structure is working and how you can make use of it for your models. So the basic information behind this new database is that we use the relational database system with a parent-child system. This parent-child system now for the first time allows that we consider the history of heat flow research on particular locations. So the child here reflects the different measurements on a specific location that could come from different authors or reflect different perturbation conditions. So metadata are really crucial to make it possible to understand the different status of data we have. For that reason, we substantially extended from 18 to 62 metadata fields as a base for quality evaluation scheme. Based on this, basically, user can really go for informed decision regarding their subject-specific requirements, which is a big progress compared to earlier times. This is needed basically to set up and to use our quality score of the International Heat Flow Commission, which considers different dimensions. The first one is the numerical uncertainty we can calculate as coefficient of erration and is reflected by the U-score here. The second one is the methodological reliability, where a detailed assessment of conductivity and temperature gradients yield to the so-called M-score. And the third one are what we call perturbation effects, so environmental effects regarding or related to the specific location of heat flow determination. That is reflected in our quality score as P-flag, and all three combined in one score is looking like that and enable us for the first time really to compare different measurements among all these different dimensions. So this is basically the technical base we used when we started the Global Heat Flow Data Assessment Project, a global voluntary collaboration to, let's say, assess global data collection of the International Heat Flow Commission. And we did not stop at the point of quality checking these data, but we also constructed a data portal to guarantee the fair access to data for the international community and to foster that way international collaboration as well. So how does the results look like? Here in the first place, we can show that we substantially expanded literature and data in our global survey. So on the left side, you see the heat flow per year that reflects the columns or the bar charts here. On the right side, that is the cumulative number of data for the line chart here, and in gray we have the data from 2002, in green 2025. So we see that we have substantially increased both literature and data. So we almost doubled the literature and we nearly tripled the number of data points and data locations for heat flow available. So this is a substantial progress coming from our assessment if you consider the total number of locations, then the European Atlas of Geothermal Resources provided 3,700 location data for heat flow, and this substantially increased to more than 8,400 locations available in this present work. So you, as a user, you will find much more data, much more information, and we provide less uncertainty in that sense. But that are only the numbers of locations. Since we now allow that we could have mutable measurements at the same location, the number of available measurements is substantially higher. So if we consider this, we see that we have close to 28,900 measurements available here. With that, we see that we consider multiple entries per location, and we do not only maximize or increase the number of measurements, but also the numbers of metadata. So the space of information really increased compared to the last worker photo. So beyond of that, we also provide new dimensions for subsurface data evaluation. So now we can evaluate on a spatial scale about the numerical uncertainty. We can do this related to the different methodology, and of course with the different climatic effects as well. So you have far more information and metadata fields that you can use for your user-defined selection of data. We are convinced that this helps to reduce overall risk in a way that you as a user better understand the data you're using for your geothermal model applications. This also offers you as a researcher a chance to really look into details and to select your preferred methods and tailor the data set you need, let's say, for your specific applications. I mean, heat flow is not only used by geothermal explorationists, it's used by lithosphere researchers, it's used by biologists, oceanographers, so by a lot of different branches of science. And I think we made substantial progress in extending the number of data and to provide added value by this kind of quality scoring and the multi-trial data we reflect. In terms of the overall success and the overall surface heat flow of continental Europe, this number averages to 66 based on a number of different references we used. You see on the left the standard deviation of these kind of statistical kriging also reflects the density of the available data we have. But there's one good news. If just consider the urban surface heat flow, so in areas with population bigger 500 people per square kilometer, then we see that the mean urban heat flow in Europe is even larger than on average. Where to find everything? So if you want to use these kind of data, we are really invited to go for www.heatflow.world. This is a new global heat flow community portal that provides access to data, publication, researchers, institutes, software learning, samples, and services. So this is where you can start your new own heat flow projects, find the news data, can ask questions, get an interaction with other heat flow researchers, and will always find the latest information regarding the topic. Both projects, the World Heat Flow Database project and the World Heat Flow Portal, provided funding to this portal, and the basic research infrastructure is hosted as a permanent service of the Helmut Center for Geoscience, GFZ, in support of the International Heat Flow Commission. So, what did we do in 2025? We completed the data assessment for Europe and will in 2026 go to develop a new systematic correction for the data based on the detailed metadata analysis we have provided this year. We will provide the full data and the grid and release it in 2026 along with a full publication on heat flow in Europe, and all these new data will then be implemented also in heatflow.world for your use. Obviously, research-wise, we will turn from statistical derived to data-driven mapping, quite prominent. So what we started with heat flow in the past years and will complete for Europe now, we will continue with the quality control of petrophysical properties, so thermal rock properties and temperature in the next years. We are quite convinced that this supports our common vision towards providing geothermal baseload, and this is what we can do on the exploration sector to the start of the geothermal technology change to support all users who would like to use and establish geothermal as baseload. If you are a scientist, you are very much invited to collaborate, to get in contact with members of the International Heat Flow Commission or with members of my team. We would be quite happy about that. If you're from industry, donate your data. If you have hidden data treasures that are not accessible, you're very much invited to share it, and we would like to help you with that. If you don't have data, don't worry, donate your money. These kind of voluntary scientific works requires financial support. You are very much invited to join this group of supporters of our work, and the Heat Flow Fellowships require your funding as well. With that in mind, I pretty much would like to thank all the contributors to the European database and would like to thank you for your attention.